is Lab 18, Example 1. We have the quadratic equation 6x squared plus 2x minus 8 is equal to 0. What we want to do with this is we want to use the discriminant to determine the type of solutions of the following quadratic equation, which is this, and then determine the solutions in simplest form. So first off, we're going to talk about what discriminant is. So a discriminant is the discriminant d is equal to b squared minus 4ac. Now this term is derived from the quadratic formula. The quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac divided by 2a. If you'll notice, the discriminant is the inside of this square root right here. And the discriminant alone can tell us a lot about what our quadratic equation will do, what our solutions will look like. So if our discriminant is positive, the inside of the square root is positive, our parabola will have two real roots. We'll have two real x-intercepts, is what that is. And it'll look kind of like this. It'll touch the x-axis twice. If our discriminant is 0, if this is 0, this plus minus will go away, and so we'll just have one solution. So we'll just have one real root. We'll just have one area where it touches the x-axis. Now if our discriminant is negative, if it's less than 0, then that means that the inside of this square root is negative. And if you remember from Lab 17, if we have a negative in a square root, that essentially means that we can rewrite it as using I, which is the square root of negative 1, which means it'll be an imaginary number. Now if we have two imaginary roots, that means that our function will never touch the x-axis. And so you see here's an example of a parabola with two imaginary roots. It never touches the x-axis in the real world, and so it's sort of just floating right here. So now that we have that, we're going to find the discriminant of 6x squared plus 2x minus 8. So if you remember, the discriminant is d is equal to b squared minus 4ac. And also this is in the format, any parabola is in the format of ax squared plus bx plus c. So when we say b and a and c, we're referring to the numbers a, b, and c in this format like this. So our a is 6, and our b is 2, and our c is negative 8. So our determinant is equal to b squared, which is going to be 2 squared, minus 4 times a, which is 6, times c, which is negative 8. And if you plug that into a calculator, you'll find out that our discriminant is the number 196. Now 196 is greater than 0, so we know that this quadratic equation has two real roots, and it will have two real solutions. It will have two x-intercepts. So we know that d is greater than 0 because 196 is greater than 0. We'll have two real roots. So now let's find out what those roots are. And we're going to do that by using the quadratic formula. So x is equal to negative b plus minus the square root of b squared minus 4ac divided by 2a. If we plug things into this equation, we have negative b, which is negative 2, plus minus the discriminant, which is 2 squared minus 4 times 6 times negative 8, divided by 2 times a, which is 2 times 6. So we already simplified the inside of this square root up here. So we know that this is negative 2 plus minus the square root of 196 divided by 2 times 6, which is 12. And the square root of 196 is equal to 14, so this is equal to negative 2 plus minus 14 divided by 12. So now we're going to split this up into two solutions using the plus minus. So we're going to have, on one side we're going to have the plus, and one side we're going to have the minus. So we'll have negative 2 plus 14 divided by 12, and negative 2 minus 14 divided by 12. And this is going to equal, So negative 2 plus 14 is 12 over 12. That's just going to give us 1. So this is 1. And if we have negative 2 minus 14, that's negative 16 divided by 12, which simplifies to negative 4/3. So we have two solutions, two real roots, where x, remember these are equal to x, where x is equal to 1 and x is equal to negative 4/3. Which means, if you think about it, these would be at two different points. These are also our x-intercepts. And our x-intercepts would be at the point 1, 0, and negative 4/3, 0. So these are our x-intercepts and our real roots.